Hello friends, today we are going to solve the 22nd question of Codevita. If you have not seen the previous questions, then you can follow them as well. You will find the link below in the description where you will find all the questions that we have ever solved of Codevita, and these all questions are of previous year Codevita questions itself. So must watch those questions before attempting your final one. So today we are going to see the second one question, that is the question of Codevita, and that is digit pairs. So till now we have already solved dole out Cadbury, and which is the C problem, and the E problem, that means grooving monkeys. Well, this is the digit pairs. Apart of that, you can also see the Swamber problem as well. So today let's see the digit pairs. Let's understand its logic and then we'll understand its implementation. My name is Anchal and you are watching our channel, The Insight Coders. Let's begin. So what does the problem says? A problem is a lengthy problem. Let's see what it says. Here you will be given n 3-digit numbers and your task is to find the bit score of all the numbers and then find the total number of pairs that are possible. Now what are this bit score? What is this pairs? What is this all? Let's see. So here you are given two rules. Let's not understand the rules here. Let's see in our slides and then understand it in a better way. Well, all you have to remember is the very first for the input format is you have to take the n, and the n is basically the count of the numbers, and further in the next line you have to take these n space separated 3-digit integers which are space separated, and finally you have to print the number of bit pairs. Well, the time limit is only 1 second. So let's see how it works. Well, let's not see the explanation and this everything here. Let's go to our slides. So here, as per the question, we are given that the value of n will be 8. So what we need to do, in the second line we have to take 8 space separated 3-digit numbers as an input. The very first is 234 and 567. Well, this is the test case given in the question itself, and similarly we are given these 8 space separated 3-digit numbers. We have to find the bit score and after that the final number of pairs. So let's understand what actually is bit score, and we have to do some steps to come to the bit score. Okay, the very first step is we have to find the score, which consists of 3 steps. We have to separate the digits, find the maximum minimum out of that, and finally find the score, whose formula is this, which is already given in the statement itself. So what we are actually doing, say let's take the first digit, the first number, that is 234. The very first task was to separate the digits. So I have separated the digits, that is 2, 3 and 4. These have been separated. Now from the 3 digits we have to find which is the minimum one and which is the maximum one. So minimum was 2 and the maximum was 4. Now we need to find the score, and for finding score we have been given a formula in the question itself which says score will always be equals to max into 11. So 4 into 11, that is 14, and min into 7, that means 2 into 7, that is 14. So 44 and 14, now we need to add them and the final score would be 58. So corresponding to 234, we have the score as 58. Similarly, when you will apply the same formula for other 7 numbers as well, you will find 112, then 40, followed by 76, 40, 11, 119 and 18 respectively. So for these 8 space separated 3-digit numbers, we have the score as follows, which are found by using these particular 3 steps. Alright, I hope this would be clear. If not, you just can trace it out on your pen paper and you will understand it. Well, our next step is we have to calculate the bit score, but till now we have only calculated score. So as per the question, what is bit score? Actually, bit score is that value. You have to take the score itself, but it is given a there is given a condition that you have to take only 2 rightmost digits. That means here only we have 2 digits. That means we have to use 58 directly. But here in 112, there are 3 digits and we need to find only the last, that means rightmost 2 digits. 0 digit and the first digit. So how would we do that? For that, I have taken a remainder, that is I have just divided it by 100, and whatever the remainder is, it will always be equal to the 2 rightmost digits. So similarly 58. Then 12, here 1 is rejected. Others are only 2-digit numbers. But this 119, here we only need 19. So same formula is required here and so on. So we have founded our bit score values as well. And what is the bit score? Initially we have the input where we have 8 and space separated 3-digit numbers. Further we founded the score and we have done it using 3 steps, and these are the further those steps. After finding the score, we have found it such that we have found the only last 2 rightmost digits, and these are in the bit scores. Now what is our next task? This was the first task. The second task is to find the number of pairs. What is it? So all you need is, here these are the index of this bit score. If this is an array, then it would start from 0. So what are the even index? 0, 2, 4, 6. So even 1 are written here in the even list, while odd 1, that is 1, 3, 5 and 7 are written here in the odd list. Well, I have written this separately because I just want to explain you the logic. What is the logic behind it? So till now we have got like we have just distinguished the even one and the odd one. Our next task is to find the MSB of even and odd. Now what is the MSB? According to them, MSB is the 10th place digit of each and every of these elements of bit score. That means 58 will have 5, from 40 will have 4, this 40 will have 4, and finally if I say these would be the MSBs for each and every one of them. Next task is to find the pairs among these MSBs. Now what's that? So what you need to do, you have to make the pair of 5 with all the MSBs in the even list. That means 5 with 4, 5 with 4 and 5 with 1. 5 is not equals to 4. Again the 5 was not equals to 4 and 5 was not equals to 1. That means till now we haven't got any pair which are equal. So let's go for all the combinations. So the next possible combinations are 4 with 4 and yes, that is equal. And then 4 with 1 and that is not equal. And finally the last possible combination, that is 4 with 1, again that is not equals. So these were the possible pairs from which we have to take such pairs in which the MSB values are equal. So 4 was equals to 4, that means totally we have only one pair in this case. While if I talk about the same procedure for the odd one, like 1 will be checked with 7, 1 and 1. Here 1 was not equals to 7 but 1 was equals to 1 in this case and the last one as well. So till now I have got 2 pairs in which the values are equal. The same work is to be repeated for the next combination, that is 7 with 1 and 7 with 1. Again the values are not equal. And finally our last combination, 1 is equals to 1, yes it is, and finally we have 3 pairs. So till now we got 3 pairs from the odd list while 1 pair from the even list. Now actually what is going on? Now we have to add the total number of pairs and print the output. So the output must be 4, like 1 plus 3. But the answer is 3. And why is it so? Because one more condition is being given, and the condition is like 1 equals to 1. We have total 3 pairs in which 1 were equal. Right? So as per the question, only at most 2 pairs can be possible for a single digit. What does that mean? Say I have, how much digits can I have? Obviously 10, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Initially what we did is everyone has 0 number of pairs, because till now I am just for the initial case I am considering that no one is a matched pair. Now after that we had some like numbers. This is the same example I took in the previous slide, and here what we did is like we were comparing 1 with these, we got 2 pairs, then 7 was compared, we get none of the equal pair, again 1 was compared and we get the pairs as 3. So till now the value of 1, the value of pairs of 1 was 3. That means we have 3 pairs of 1. But for each and every digit, like for 1, for 4, for 5, for 6 and for each and every digit we can have at most 2 pairs. That means we cannot have 3 pairs. So we need to have only 2 pairs and we have to reject the third one. So all you need is to make a check that each and every one will get 2 pairs at most. So for that, for the initial state, we are just putting each and every value as 0, that no one matched pair, and we will be incrementing it side by side with the condition that we cannot increment it above 2. Let's see the code which is completely working as per this question. So this is the editor. Since my program was in C++, I just selected C++ from here. Otherwise, you can select whatever the desired language you will prefer. So you must have to make a check that here also the extension is being changed. If not, then again you can select the language, then it will change itself. Write the program name. Say I've just written A. You can write anything, whatever it is your choice. Now see, the very first is my function which is bit score. What I am doing, we always have to separate the digits. So for separating digits, because it is always a 3-digit number, I am using a direct function from which I am separated the digits. After that, we have to find the maximum and minimum from that digit. So for that, I have used a ternary operator, a conditional operator. You can do it in any of the way as you feel comfortable. After that, we have to find the score, and the score was max into 11 and min into 7, and then we have to add it. We only need rightmost 2 place digits from that, so I just modulus by 100, and finally we have returned the score. Well, there is one more function, that is SRC pairs. What actually is going on here? Initially, for all the sign bits that I have shown you in the last slide, for each and every sign bit, that 0, 1, 2 till 9, we have kept the sign bit value as 0. That means initialized it by 0. It will work differently for the even pairs, while it will work differently for the odd pairs. Let's see how it works. So for even, I am starting a loop for I, in which I am using another loop j. Every time j is being incremented by 2, and that means with I plus 2 I am starting. That means for even, because I am starting from 0, that means 0, 2, 4, 6 and so on. Each time we have to calculate the MSB, that means the 10th unit place digit. So it's simply divided by 10 and you will have the question, and the question itself will be always be the leftmost digit from that. And every time for this, you have to increment the sign bit if the values are equal. That means if this MSB is equals to the array score, that means this itself, and its jth position, that means both the MSBs are correct. Where here in the sites, what actually we were doing, we always used to have a different list, since we are not doing it in the Python right now. So what is actually doing, we are not taking a separate list. That was just for explaining you it in a better way. Here we are doing it by nesting loops. You can also take it in another list and do the same work, but keep in mind the time limit should not be exceeded. So here the loop is going over for, these loops are for like the even pairs, and MSB for the first one and MSB for all others. If the MSB, the sign bit is not less than 2. Now the students mostly ask why less than, why not less than equals to? Because here I am using plus plus, that means post increment, and each time it will increment it as well. So need not take it equals to. Okay. So other thing, the same thing is being repeated once again for odd pairs. What is the difference? Here I am starting from 1. That means 1, 3, 5, 7 and so on. Else, otherwise everything is same. And finally, after these pairs, we have to print the result. Like for each and every sign bit, we will have some values. Say 2 for 1 and 1. And 1 for 4. So every time each and every sign bit will be added, and that P will be returned to main, and finally we'll print that as a pairs. So here we have used that SRC pairs, and here we are using that bit score. Well, this was all about this question. Let's see whether this will be submitted or not. So the compilation is done, and here it is being accepted for the sample test cases that they have given. Let's submit it. And finally, it is being submitted against all the private test cases, and it is being accepted. So this was all about this question. For any doubts or any suggestions, you can tell us in the comment box. आई होप आपको ये वीडियो लेक्चर पसंद आया होगा। अगर आपको कोई भी डाउट या सजेशन है तो आप कमेंट बॉक्स में जरूर दीजिएगा। और अगर आपने वीडियो को अब तक लाइक या शेयर नहीं किया है तो जल्दी से वीडियो को लाइक और ज्यादा से ज्यादा शेयर करें। एंड प्लीज सब्सक्राइब माई चैनल एंड प्रेस द बेल आइकन्स फॉर लेटेस्ट अपडेट्स। शुक्रिया, धन्यवाद, थैंक यू।